Hello and welcome to this week's set of short videos on software-based products. Today we're going to talk through how to transition from storyboards and mind maps into implementing codes. How to move from storyboards to use cases, how to specify the expected behavior of a software through use case, activity, sequence diagrams. What is object-oriented design and how is it used to model concepts from the real world into software? What are events and how do they drive connected and distributed software-based products? But first, let's look at an example, the connected doorbell. We will use this example throughout the lecture video to illustrate the concepts and methods that we introduce. We developed a basic example of connected home, which you will get familiar with in the 8th Python programming assignment. It involves a server implemented in Python, which receives data from devices in the house and establishes the logic between them. This is also a web server, as it receives and serves information over the HTTP protocol, directly accessible in the web browser, for example. And this is what we are looking at here. A web page that lists the devices that are simulated on the Python server. So let's focus on the connected doorbell. We've organized the house in rooms in a broad sense, where the street side is also a room. In the street, we have an outdoor lamp, a motion sensor to detect if there is an activity, a visitor would have the ability to ring from the doorbell button, and a camera is available to give a glimpse of what's going on. We consider the entrance door as part of the room entrance. Along the bell itself, a door push button to manually unlock the door from inside. And we could imagine that there is a switch to turn on the light in the room. We added the living room with a presence for the whole house, as for example, an indicator of occupancy in the house. All these devices call for multiple scenarios, and that is where the design of the software, the logic behind the scene, comes into place. I can, for instance, click on the doorbell to ring it manually. Same outdoor for the camera. But what is the point? It only becomes useful when there is an intended scenario to bring value. A typical use case for a doorbell is to have a visitor requesting to access the house. For instance, a user can press the doorbell button, which would trigger the bell in the entrance. I press, it rings. Release, it stops ringing. Now, we assume that the householder is at home, hears the bell, walks to the entrance, and presses the door button, which in turn would unlock the door. Now we could imagine that the motion sensor in the street rings the bell, or maybe not. That might be quickly annoying, leading to our customers to switch back to a very traditional disconnected doorbell. No, we could turn on the camera when we detect some activities in the front door. Let's click on the motion sensor to simulate some activities. We have a sign of activity here, and it turns on the camera. We can now see who is at the door. The camera could also be triggered by the doorbell button. This is definitely a design choice. This is obviously the camera of my laptop, and no video stream is leaving my web browser to reach the server. The server could receive the video stream to forward it to a screen in the house or on the smartphone app of the householder, for instance. Here we thought we could process the video stream locally on the camera itself. So it could detect emotions and open to the visitors who show the right emotion only. We choose the surprised emotion, for instance. So when I look surprised, we can see the door unlocking and I can click on the door to open it. In this model, we will focus on these scenarios using use cases, activity, and sequence diagrams to specify them. How does it look on the server? Well, let's have a look on the Replit project. In the file main.py, we have the setup of the routes, what the server should send to the web browser and receive. Then we have the relevant elements for our software. We can see that we create a house and a phone. Then we have the elements that we want on the street side. A connected lamp, a push button for the doorbell, a camera, etc. We add all these to the room street side, and we add the street side to the house, and so forth, the entrance and the living room. This is a major topic of this week: object-oriented design. Writing the code in a way that reflects the object that we handle. These objects are specified in the code as classes. This is the mold to create objects. Let's have a look at the doorbell, for example. We see that we define a class doorbell. It has states, something it can keep in memory, such as whether it is on or off and the tune that it should play. And it has behaviors, the functionalities that it can perform, such as the ability to start or to stop ringing. It is a device, and because most of our objects are devices in the connected home context, we created a class device with some states and behaviors as well, which our doorbell has and can perform too. We say that it inherits these functionalities. We will explore this further in the second lecture. So we have a server with objects to play with. The missing element here is links between these objects. We connect the behavior of our objects via events. For example, the doorbell button emits an event telling the rest of the system that it is currently pressed. In this situation, we want the doorbell to start ringing. When the door button in the entrance is pressed, we want the door to unlock. And so on. We refer to this mechanism as event-driven. This example of doorbell is the end result of the 8th Python programming assignment. It gives you an overview of the topics we will discuss this week. We look at the steps to transition from the storyboard to the code, but we will leave the coding part for the programming assignment to focus on the specification process, looking at object-oriented but also event-driven paddings along the use case, sequence, and activity diagrams.